자, 다음은 Reality on Chain이라는 주제로 OmiseGo 연구원 데이비드 넛의 강연이 있겠습니다. 큰 박수 부탁드립니다.
Hey. I'm David, and today we'll be talking a bit about reality on chain. Should be fun. Let's do it. Cool. So we have a blockchain. In our case, it's Ethereum, and Ethereum is wonderful. It can do a lot of things. Virgil just did a wonderful job telling you all about what's happening and some of the cool things you can do within the Ethereum ecosystem. But Ethereum has an issue right now, and actually most blockchains, especially most public blockchains, have this issue where they're essentially fairly closed systems. So when you're interacting with a smart contract, you have certain guarantees. Everyone essentially can view this smart contract, and if this condition is met, you can have confidence that something will happen. That essentially the smart contract logic will work how you expect it to. Now, once we get into the real world, you don't have these assurances, and this is one of the reasons why smart contracts are so valuable. Unlike legal contracts, where there is an incredible amount of wiggle room, with smart contracts, all of a sudden the onus is actually on the contract writer. If it's not included in the code, it won't happen. And so, yes, this is very exciting. But now, we essentially have to connect the two, because for public blockchain technology to have an impact in the real world, we have to have reliable ways to get information of about what's happening all around us into the public blockchains that we're using. And there are many projects working on this right now. Today I'm just going to give a brief overview of a few, what they're doing and why they're doing it, and why they've chosen their specific path. Cool. So yeah, essentially blockchains, public truth, everyone can see, right? As soon as we get off-chain, everything is essentially subjective, right? Everyone has their own frame of reference. And this really is the issue. There's no philosopher king. There's no benevolent dictator that we can just use to get information about the real world, who we can trust to essentially convey any information we need onto a blockchain. And even if there was a benevolent dictator, we wouldn't want to build all our systems on them, because the whole beauty of public blockchain technology is resilience through diversity. We don't want to have weak links. Weak links are what cause systemic failure in the long term. And so we're trying to minimize or eliminate them whenever possible. And so absolute truth is here. I kind of tend to think about it as a global perspective, and when we're dealing with public blockchains, we have this global perspective, right? This global truth that anyone can add to, operate on, read from, and access. But then we have relative truth. And relative truth is where I could be having a conversation with any of you. And that conversation is happening, it's real, but no one else needs to know about what's being said. That information is essentially just between us. The information is being exchanged, and it's great. And the beauty of this is that it actually doesn't need to be on a public blockchain for the most part. Having relative information in many situations is okay. But then all of a sudden, we make some sort of agreement. Say we make a prediction, we make a bet on this prediction. All of a sudden, relative information exchange isn't good enough once you have significant economic incentives or significant amounts of value on the line. And so this is where we would try to transition from relative truth into more absolute truth. And so in the case of, say, a bet or a prediction, we could agree on something, but then we put it on, say, a public blockchain, and we use that as the arbiter. We'd use that to determine the winner, as opposed to having to trust the counterparty. And this is really an important point to grasp. What we're essentially doing is we're transferring trust. We're not eliminating trust, but we're just transferring trust from counterparties onto blockchains, essentially. And the beauty of this is that there are just more people, more parties involved in running these blockchains, and so we have stronger guarantees than when we're interfacing with an individual or like one single counterparty. So this is pretty cool. But all of a sudden, once we put said prediction on a blockchain, we need a way to find out who has won, essentially, because it's easy for us to lock up value on a public blockchain. We can both sign, it's locked up, but who determines the winner? And this is really a prime example of where we need reliable oracles. So what is an oracle? An oracle is essentially a way of getting information about the real world onto a public blockchain. And there are many different ways to do it. The simplest way would be to use a centralized oracle. So like one entity that's responsible for determining the winner of a prediction. They send a transaction on Ethereum, say, and then all of a sudden, boom, it's resolved, done. But right, once again, don't want to rely on the weak link. And so many people are exploring more decentralized and different ways to resolve predictions, which is super fun and exciting. One potential and one use case that I'm fairly heavily involved with in terms of using oracles is actually with Plasma. And to be frank, pretty much all layer 2 solutions. So essentially, layer 2 solutions are pretty awesome because they essentially allow you to transact for cheaper and in many than on, say, a base layer chain, and also in many cases faster. The downside is that if anything goes wrong, essentially you have to go to the base layer. And in most cases, this is an advantage. In most cases, you want to go to the base layer because it has stronger security guarantees. But, using Ethereum as an example, say something goes wrong on a Plasma chain or in a state channel, and all of a sudden you have to go down to Ethereum to resolve what went wrong, who messed up essentially, and to essentially take value away from them, to punish them for it. And all of a sudden you have to use the base layer. And right, fine in most situations, but let's say Ethereum is experiencing a tremendous amount of network congestion. All of a sudden, you or your users may not be able to make time-sensitive transactions, and so that's a huge issue. And so essentially, to be able to counter this issue, it would be super helpful for layer 2 solutions if we had a reliable way to gain information about network congestion, to gain information about things that are happening external to the system. Because then, in the case of Plasma, say, we could determine and make essentially challenge and response periods dynamic based on network congestion. So if Ethereum is super congested, we would have longer challenge periods. And this would be great for everyone involved because no one wants to pay high gas fees just to compete with the token sale that's happening. In many cases, people are fine waiting, and if they're not fine waiting, there are things we can do to deal with that. But at the very least, we'll give them the option via dynamic time periods. And so, how are current projects dealing with this issue? So, MakerDAO is a super awesome project. Thank you. They are essentially creating a stable coin, but how they ensure stability is through over-collateralization, which is super cool, exciting. But essentially, to maintain stability, they need a price feed. They need to interact with the outside world. Their stable coin, DAI, is supposed to be equivalent to the value of 1 USD. But how can they track the exchange rate, right? At least right now, that's information that is external to the system. Currently, within the world of Ethereum, there's no non-tamperable, reliable way to get access to price feeds. Yes, we have decentralized exchanges, and they can work to an extent, but quite frankly, there's not the liquidity there to make it non-trivial to tamper with. If, say, Maker was to base their entire DAI ecosystem on decentralized exchanges for pricing information. And so what Maker actually does is they use a combination of centralized exchanges. They essentially use multiple centralized exchanges and combine the price feed. And they've said that down the road they're interested in kind of moving away from this, but it's a fairly pragmatic option right now to gain reliable price information, which is necessary for their system to work and for stability to be maintained. So essentially, one way to gain information that's about the outside world that's safer than using one is using a bunch of trusted parties. This is, I would say, not optimal, but a fairly good choice for now. So, right, we have Bob 1, and just kind of going off him, he could be wrong, right? We don't want to rely on just, say, one centralized exchange for a price feed. We want to rely on as many participants as possible. And this kind of moves us into the realm of prediction markets. Prediction markets are super cool. Essentially, it allows people to make a prediction, and they allow anyone to participate in making in either side of said prediction. And the really valuable thing about prediction markets, yes, they're fun to use, but you can actually use what's called the wisdom of the crowd to gain some varied information about future outcomes. Because in many situations, when you have a lot of people participating in prediction markets with value on the line, they can actually predict real-world outcomes fairly accurately. So yes, we could have a prediction market with just Bob, and that would be fine. It wouldn't give us that information. But all of a sudden, when you have 1 million people involved in a single prediction market together as a group, we can actually gain a bunch of useful insights, which is pretty awesome. Then there's Augur. Augur has been around for a very long time. They're now up and running. They're currently based off Ethereum. They're super exciting prediction market because they kind of take a different approach than just using kind of like trusted parties. Essentially, what the Augur prediction market allows users to do is it allows users to make a prediction, and then they can actually choose who they want to trust for said to essentially give the outcome. of said prediction. And this is all publicly available. So now, all of a sudden, for each given prediction, you can pick the best party or parties possible to resolve said prediction. And this is a fairly huge step in the right direction. It doesn't necessarily solve the Oracle problem, but it definitely brings us significantly closer. And on top of that, Augur brings in an aspect of collateral, which is super cool. So not only do you pick the party who resolves disputes, but you have them collateralized, and essentially you have challenge phases if enough people feel like they've made an incorrect resolution. And so this is awesome. One downside is that even though I would say it's more stable than other mechanisms, it also costs more to use, because when we're talking about blockchain technology, they're really expensive to use. So increased complexity, more expensive to use. So yeah, that's kind of like, I would say, the biggest downside to Augur. And then we have Eternity, which is an entirely another blockchain. And I think it's super interesting because they actually decided to build oracles into the base level of their protocol. And so this essentially allows them to give oracles special treatment. I think this is very interesting because it's recognizing the importance of oracles and treating them as first-class citizens. And I really, like, public blockchains are great, but unless we find better ways for them to interact with the real world, I see them having a very hard time gaining mass adoption. Now, Futarchy. And Futarchy is really kind of, it's one of my favorite examples of the use of prediction markets. So Robin Hanson, an economist, coined this term, vote on values, bet on beliefs. So essentially what Futarchy is essentially where you vote for elected officials based on values, like what you believe in, and then they actually create prediction markets that anyone can use to move society towards better outcomes. So an example of this would be there's a vote, elected official, someone becomes elected. Now all of a sudden they have a goal for society. Let's say the goal is to increase literacy rates. Enough people agree on this. But there's a bunch of potential ways to deal with this. And so there could be a bunch of prediction markets where anyone can participate and actually stake value on the best way to do this. And so this essentially gets the masses involved in political decisions, because all of a sudden they can have something at stake for each decision. And yeah, this isn't currently the case in our current political systems, at least not on the decision scale. So yeah, I would love to kind of see this progress, both within the blockchain ecosystem, but yeah, try out new governance mechanisms in the real world too. Awesome. Yeah, it's still super early days, especially in the world of decentralized oracles, and there's a lot of research being done in terms of how to do it better. This is a super old map, and I feel like this is kind of where we are in terms of decentralized oracles. We do not have a full view of how it should be done, constantly expanding said view and learning more. Cool. Yeah, any questions?
질문 있으시면 좀 던져주세요.
Hi.
Hey.
Yeah. So I saw you used Maker and Augur as some examples to kind of describe different types of oracle or different way we can bring the reality onto chain.
Yes.
Except I find Maker's current oracle price fit as so faster than what Augur is doing. he said it may be less reliable, while I believe the auger system is relatively much more reliable. And currently, as far as I see it seems like there's a dilemma. You can either take a fast but less inaccurate way to get a reality onto chain, or more accurate but slower, complicated way. But do you see any point where we can catch those both values by any way? Maybe
Yes, eventually. I would say right now you're very correct about that trade-off. In general, base layer, like working directly on base blockchains such as Ethereum, is relatively slow. And for financial products especially, such as Maker, they can't really afford to move at blockchain speeds. And so that's where like having price feed from centralized and like trusted parties comes in super handy, because price information changes like that. I would say probably looking at like either, depending on what you're building, either like layer 2 solutions seem like a very good balance, where you still have like a lot of the same security properties as working directly with Ethereum without having to deal with a lot of the scalability stuff. Yeah, so I would explore layer 2 further for that, particularly plasma chain. It'd be super cool to see a plasma chain that handles prediction markets, and as we kind of get closer to being able to do more complex stuff with like plasma architectures, I think, yeah, good chance we'll see that happen.
수고해주신 데이빗 낫께 박수 부탁드리겠습니다. Thank you.